Are you ready to discover a truth that might keep you awake tonight? The universe is so big that your brain will struggle to even imagine it. Stick around, because by the end of this story, you might never look at the night sky the same way again. And hey, while you're here, hit that subscribe button so you don't miss the next journey. Now, let's take a breath together. Slow down. Imagine yourself lying on your back under a clear night sky. The stars look close, like tiny glowing holes poked into a dark blanket. But here's the thing. Those little dots are not close at all. They are oceans of fire, trillions of miles away. And yet, those are just the beginning, the tiniest tip of an iceberg so massive we can't even see its edges. That's what we're going to explore tonight, how big the universe really is. So, let's start small, because that's where everything begins. Imagine Earth, our home. It feels big to us, right? We spend our lives walking across continents, flying across oceans, and still there are places on this planet we'll never set foot on. Earth's circumference is about 40,000 kilometers big enough that walking around it would take years. But if you step back, if you look from space, Earth becomes a little blue marble, a speck floating in nothing. Now, think about the moon. Just a short 384,000 kilometers away. That sounds huge, but in cosmic terms, it's basically next door. You could fit all the planets of our solar system between Earth and the moon, side by side. That's how much empty space there really is between us and our nearest neighbor. From there, our next step out is the Sunday, a giant ball of fire 100 times wider than Earth, so huge that over 1 million Earths could fit inside it. And yet, the sun is tiny compared to what's out there. It's just one star among hundreds of billions in our galaxy. But here's where the scale gets wild. Light itself, the fastest thing in the universe, takes about 8 minutes to travel from the sun to Earth. That means when you step outside and feel the warmth of sunlight on your face, you're actually touching light that left the sun 8 minutes ago. You're literally living in the past. But if we zoom out again, past the sun, past the Mars, Jupiter, and Saturn with its rings, we reach Pluto, the edge of our solar system. If you were traveling at the speed of light, it would take about 5.5 hours just to get there. Hours at the fastest speed possible. For humans, with current spacecraft, it would take over a decade. And that's still just our backyard. The next frontier after the solar system is the Oort cloud, a vast bubble of icy bodies surrounding our sun like a distant shell extending almost halfway to the nearest star. The Oort cloud is so big that it would take light about a year to cross it. That's 1 year of moving at 300,000 kilometers per second just to leave home. And here's the kicker. The nearest star to us, Proxima Centauri, is 4.2 light years away. That means if you could somehow ride a beam of light, it would still take you more than 4 years just to shake hands with our closest stellar neighbor. With our current rockets, it would take tens of thousands of years. Imagine that. If humanity sent out a ship today, the people who launched it would be long gone before it even got halfway there. Now take a deep breath, because this is where things get truly mind-bending. Our galaxy, the Milky Way, is home to about 100 to 400 billion stars. Not million billion. Each one could have planets, moons, entire systems of their own. And the size? To cross our galaxy from one side to the other, light would need 100,000 years. 100,000 years, moving at the absolute speed limit of the universe. That's how wide just our galaxy is. And here's where it gets even crazier. Our galaxy is not alone. It's one of billions. In fact, the observable universe, what we can see, contains over 2 trillion galaxies. That's 2 trillion Milky Ways, each filled with billions of stars. When you look at the night sky, those dots aren't just stars. Many of them are entire galaxies, each one containing more suns than you could ever count. But here's the twist. That's just the part we can see. Scientists believe the universe might be infinite. What we call the observable universe is just a bubble around us, limited by the speed of light and the age of the cosmos. Beyond that bubble, we don't know. Could be more galaxies, could be nothing, or something stranger than anything we can imagine. Let's pause here for a moment. Picture it in your mind. Earth, a marble. The sun, a giant. The galaxy, an ocean of stars. And then, trillions of galaxies stretching into a darkness that has no end. It's overwhelming, isn't it? But it's also calming. Because no matter how big your worries feel, out there, they're smaller than dust. Now here's a thought that scientists wrestle with. If the universe is so big, if there are so many stars, so many galaxies, then where is everybody else? Where are the aliens? Shouldn't we have seen them by now? That's the mystery called the Fermi paradox. With billions of potentially habitable planets, the odds say we shouldn't be alone. And yet, so far, silence. Maybe civilizations are rare. Maybe they rise and fall before they can spread. Or maybe they're out there, looking at us the same way we're looking at them, wondering if they're alone. And here's the haunting part. The deeper we look into space, the further back in time we see. Because light takes time to travel. When you gaze at a galaxy millions of light years away, you're not seeing it as it is now. You're seeing it as it was millions of years ago. Looking at the stars is like reading history written in light. The night sky is a time machine. So, how big is the universe? Big enough to hold mysteries we can't even put into words. Big enough to make us feel small, but also connected to something vast, eternal, and beautiful. So, let's go a little deeper. If you step outside on a clear night, look up, and just let your eyes rest on the stars, what you're actually seeing is only a paper-thin layer of the universe. Think of it like looking at the surface of an ocean. You're only seeing what's right there on top. Beneath that surface is an unimaginable depth that stretches further than your mind can really picture. The light you see from those stars? Some of it has traveled for hundreds of years, some for thousands, and some for millions. Imagine a single beam of starlight leaving its home star long before you, your parents, or even your entire civilization ever existed, and finally reaching your eyes tonight. That's how enormous and ancient the universe is. Now, let's put some size into perspective. The distance between the Earth and the Moon is about 384,000 kilometers. If you were to drive that in a car, never stopping, going at highway speed, it would take you about 6 months. That seems huge, right? But that's barely scratching the surface. The distance from Earth to the Sun is about 150 million kilometers. That's one astronomical unit. Light, which moves faster than anything in existence, takes a little over 8 minutes to travel that distance. Now here's where it gets almost dizzying. The nearest star system to us, Alpha Centauri, is about 4.3 light years away. If you hopped on the fastest spacecraft we've ever built, it would still take you over 70,000 years to get there, just to the nearest star. Let that sink in for a moment. And Alpha Centauri isn't special, it's just one of hundreds of billions of stars in our galaxy, the Milky Way. Imagine flying through space for thousands of years, star after star, nebula after nebula, and realizing you're still stuck inside a single galaxy. That's how big just one galaxy is. The Milky Way itself is about 100,000 light years across. That means if you turned into a beam of light moving at the ultimate speed limit of the universe, it would still take you 100,000 years just to cross our galaxy from one side to the other. And remember, this is only one galaxy. Scientists estimate that the observable universe contains about 2 trillion galaxies. Trillions. Each filled with stars, planets, and who knows what else. Let's slow down here and think about what observable actually means. The universe itself is bigger than what we can see. What astronomers call the observable universe is the region of space from which light has had time to reach us since the beginning of the cosmos. That region stretches about 46 billion light years in every direction. Not million, billion. Which means the full diameter is about 93 billion light years across. And yet, even that massive size might only be a tiny fraction of the whole. The universe could go on forever without edges, without an end, without a boundary. We may never know. Now, here's a strange problem to think about. If the universe is so big and filled with trillions of galaxies and stars, why does the night sky look mostly dark? Why isn't it glowing bright everywhere you look? This puzzle actually has a name, Olber's paradox. The answer is connected to the fact that the universe isn't infinitely old. Light from the most distant galaxies simply hasn't had time to reach us yet. Combine that with the fact that the universe is expanding, stretching space itself, and distant light is forever slipping out of reach. So, in a way, the darkness of the night sky is not emptiness. It's a reminder of just how enormous the universe is and how much of it lies beyond what we can ever see. Now, imagine this. Each galaxy isn't just a dot in space. It's its own island universe, filled with hundreds of billions of suns, planets, moons, black holes, and mysteries we can't even imagine. Our galaxy is only one of these islands. Picture yourself floating gently out into space, far away from Earth, far away from the sun, until the Milky Way self becomes just a glowing spiral behind you. Now imagine drifting even farther, until the galaxies themselves begin to look like tiny grains of sand scattered on a dark ocean. When you picture that, you begin to realize asking, how big is the universe? Is like asking, how endless is endless? It doesn't fit into the way we normally think about size. So, let's keep floating outward. Imagine the galaxies around you, each one glowing like a lantern in the darkness. Some are spirals, with arms stretching out like whirlpools of stars. Some are elliptical, shaped more like smooth, glowing clouds. Others are irregular, twisted and bent, as if pulled apart by invisible cosmic tides. They are scattered across the universe in a vast cosmic web connected by threads of gravity and dark matter. And here's the astonishing part. They're not standing still. Every single galaxy is in motion. The universe is expanding, which means the space between galaxies is stretching like dough rising in an oven. Imagine raisins inside that dough, each one moving farther and farther away from the others as the dough expands. That's what's happening to galaxies right now, at this very moment. This expansion was first discovered in the early 20th century by Edwin Hubble, who noticed that galaxies seemed to be moving away from us, and the farther away they were, the faster they moved. This discovery changed everything we thought we knew about the cosmos. It meant the universe wasn't static. It was alive, dynamic, and growing. Now, pause for a second and really picture this. Space itself, the fabric of reality, is stretching. It's not that galaxies are flying through space like ships through an ocean. It's the ocean itself getting bigger, which means there's no edge, no center. Everywhere you stand in the universe, it looks like everything else is rushing away from you. But here's the twist. The universe isn't just expanding. It's expanding faster and faster. You'd think gravity, which pulls things together, would eventually slow it down. But instead, something strange is pushing it apart. Astronomers call this force dark energy. We don't know what it is. We don't know where it comes from. All we know is that it makes up about 70% of the entire universe. In other words, most of the cosmos is being driven by something completely invisible, completely mysterious. Think about that for a moment. Everything you've ever seen, stars, planets, galaxies, makes up less than 5% of the universe. The rest is dark matter and dark energy, both things we don't truly understand. In a way, the universe is like a locked room where almost all the lights are out and we're fumbling around trying to figure out what's inside. Now let's stretch our imagination even further. Scientists estimate that the observable universe contains about 2 trillion galaxies. That's 2,000 billion. And each galaxy contains anywhere from 100 billion to 1 trillion stars. If even a fraction of those stars have planets, and even a fraction of those planets are habitable, then the possibilities for life out there are beyond counting. Let's put it another way. Imagine taking a handful of sand from a beach. That handful might contain about 10,000 tiny grains. Now imagine that every single grain of sand represents an entire galaxy. You would need not just one handful, not just one beach, but all the sand on all the beaches on Earth to even begin to compare to the number of galaxies in the observable universe. And that's just what we can see. But here's a challenge for your mind. If the universe is expanding, does that mean it has an edge? And if it has an edge, what's beyond it? These are questions that bend human logic. The truth is, there may be no edge at all. The universe could curve back on itself like the surface of a sphere, so that if you traveled in one direction long enough, you might eventually end up where you started. Or maybe it really is infinite, stretching forever into the unknown. Scientists don't know for sure, and maybe that's the point. The mystery of the universe isn't something we can solve in one lifetime or even in thousands. It's something that humbles us, reminding us how small we are. Think about this. Our entire galaxy, with its hundreds of billions of stars, is just a tiny part of a larger structure called the Laniakea supercluster. This supercluster stretches over 500 million light years across, containing 100,000 galaxies, and even that isn't the end. Superclusters themselves are woven into the cosmic web filaments of galaxies and dark matter stretching across the universe like the strands of a giant invisible net. And what lies between these filaments? Vast voids, huge, empty regions of space, millions of light years across, where almost nothing exists. If galaxies are the lights in a city, these voids are the endless countryside between them, dark, silent, and incomprehensibly empty. Now imagine yourself drifting into one of those voids. Slowly, you leave behind the last glowing cluster of galaxies. The light grows dimmer and dimmer until there's nothing at all. Just emptiness. Pure, absolute darkness, stretching in every direction. In that silence, you begin to feel the true scale of the universe. Not just the stars and galaxies, but the endless voids between them. It's in that silence that you begin to sense how truly vast this cosmic stage is. And here's the thought that makes it even stranger. All of this, the galaxies, the stars, the voids, the expansion, is only part of the observable universe. What lies beyond? Could there be regions of space so far away that light from them hasn't reached us yet, and maybe never will? Entire clusters of galaxies hidden forever, out of sight, beyond our cosmic horizon? When you think about it like that, the universe becomes less like a map and more like a dream, something too big, too strange, too infinite for us to ever hold completely in our minds. To understand how big the universe is, we have to step back, way back to its very beginning. Picture this. Around 13.8 billion years ago, everything, space, time, matter, energy, was compressed into a single point. Not a point floating in space, but a point that was space. The Big Bang. Now, despite its name, it wasn't an explosion in the way we imagine fireworks bursting in the sky. Instead, it was space itself expanding. Imagine blowing up a balloon. The surface of that balloon is like our universe. At first, it's small, But as air rushes in, it grows larger and larger. Every point on the balloon moves away from every other point, not because the dots are moving across the surface, but because the surface itself is stretching. That's the Big Bang. And in that first instant, the universe went through something called inflation. This wasn't just expansion, it was expansion at a speed faster than light itself. In a fraction of a second, the universe grew from smaller than an atom to the size of a grapefruit. That's like taking a single grain of sand and stretching it until it's larger than the Earth in less than a blink. Now, what's truly humbling is that we don't know what caused this inflation. We only know it happened because we can still see its fingerprints today. That fingerprint is the cosmic microwave background. Close your eyes and imagine static on an old television screen. That fuzzy static noise is almost like an echo of the Big Bang. It's a faint glow of radiation left over from the birth of the universe, still lingering in the sky in every direction we look. Astronomers have studied this glow carefully, and from it they've learned not just the age of the universe, but how it has evolved over billions of years. Think about that. Every time you look at the night sky, you're not just seeing stars, you're seeing the universe's memory. A faint afterglow that has traveled for nearly 14 billion years just to reach us. And here's where things get even stranger. The Big Bang wasn't an explosion of matter into empty space, because there was no empty space. Space itself was created in that moment. That means time itself had a beginning. Asking what came before the Big Bang is like asking what's north of the North Pole. The question itself bends reality, but the mysteries don't stop there. Some scientists believe that the Big Bang might not have been the beginning at all, just the beginning of our universe. It's possible that what we call the universe is only one bubble in a vast cosmic foam, with countless other universes expanding in their own ways. This is called the multiverse theory. Imagine endless balloons, each one representing a universe, inflating and floating in an infinite sea of possibility. Now pause for a moment. Imagine that. If the universe we live in is already too vast for our minds to grasp, what does it mean if there are endless universes beyond it? Entire realities, with their own galaxies, their own stars, maybe even their own versions of you and me. But let's come back to our own cosmos, because even without multiverses, its size is staggering. When the universe was young, it was mostly hot, dense plasma, a soup of particles. Over millions of years, it cooled enough for atoms to form. Then, gravity took over, pulling matter together to form the first stars. Those first stars were massive, much bigger than our Sunday. They burned bright and died young, exploding in brilliant supernovas that created the heavier elements carbon, oxygen, iron that would later form planets, oceans, and even life. In a way, those early stars were like cosmic forges, factories that built the ingredients for everything we know. Every atom in your body, your bones, your blood, the oxygen in your lungs was once inside a star. You are literally made of stardust. And that stardust has traveled across billions of years, through collapsing stars, colliding galaxies, and endless stretches of time to become you. Now, let's stretch this even further. If the Big Bang happened 13.8 billion years ago, you might assume the universe is 13.8 billion light years across. But that's not true. Because the universe has been expanding the whole time, the observable universe, the part we can actually see, is about 93 billion light years across. 93 billion. And that's just what's visible. Beyond that, the universe continues, maybe infinitely. Here's a thought that might keep you up at night or help you drift off into dreamlike wonder. The light we see from the most distant galaxies has traveled for nearly 14 billion years to reach us. But while it was traveling, space itself kept expanding. So those galaxies are now much farther away than 14 billion light years. Some are so far that their light will never reach us. They're effectively cut off, hidden forever. In other words, there are parts of the universe that we will never ever see. Not because they don't exist, but because the fabric of space is expanding faster than light can travel. Think of it like standing on a shore and watching ships sail away. Eventually, they cross the horizon, and no matter how long you wait, you never see them again. That's what's happening on the grandest scale possible. Entire galaxies are sailing beyond the cosmic horizon, lost to us forever. And yet, here we are on our tiny planet, staring out into that ocean, asking the simplest and most profound question: how big is the universe? The truth is, we may never fully know. Every time we learn more, the universe grows bigger, stranger, and more mysterious. It's like chasing the horizon. The closer we get, the farther it moves away. Now that we've traveled through the beginning of the universe and stretched across billions of light years, let's take a leap into the future. What will happen to the universe, not just tomorrow, not in 1,000 years, but in billions, trillions, even unthinkable stretches of time? To imagine this, you have to picture the universe like a great cosmic clock. Right now, we're living in what scientists call the stelliferous era, the age of stars. It's a time filled with shining galaxies, glowing nebulae, and the sparkle of countless suns. This is the universe at its most alive, its most brilliant. But like all things, this era won't last forever. Billions of years from now, stars like our sun will use up their fuel. Some will expand into red giants, swallowing their nearby planets. Others will collapse into tiny, faint white dwarfs. And the most massive stars will explode in spectacular supernovas, leaving behind neutron stars or black holes. Picture that. Whole galaxies, once glittering with billions of lights, will slowly grow dimmer, like a city shutting down one street lamp at a time. It won't happen quickly, it will take eons, but eventually the night sky will grow quieter. Now let's stretch our minds even further. Imagine a universe not billions, but trillions of years from now. Most stars will have burned out. Galaxies will be filled not with blazing suns, but with faint embers, white dwarfs cooling into black dwarfs, invisible remnants of stars that once gave light. But gravity doesn't rest. Over unimaginable time scales, galaxies themselves may begin to fall apart. Stars will drift away, pulled by invisible tugs. And in the end, black holes may dominate. Silent giants scattered across the universe, swallowing anything that comes too close. And here's a thought that will bend your mind. Even black holes aren't eternal. According to Stephen Hawking, they slowly evaporate through something called Hawking radiation. It's an incredibly slow process, far longer than the age of the universe we know. But eventually, even the greatest black holes will fade into nothingness. So what does that mean? It means that in the farthest possible future, the universe may end in a cold, dark silence. No stars, no galaxies, just endless space, stretched thin, colder than the coldest winter night you can imagine. Scientists call this the heat death of the universe, a time when everything is so spread out that nothing more can happen. No energy, no life, just emptiness. But that's only one possibility. Another theory says the universe could end in a big rip. Right now, the universe isn't just expanding, it's expanding faster and faster thanks to something mysterious we call dark energy. No one knows exactly what dark energy is, but it makes up about 70% of the universe and is pushing galaxies apart. If this acceleration keeps growing, then in the far future, galaxies won't just drift away, they'll be torn apart. Stars will be ripped from galaxies, planets torn from stars, and eventually even atoms themselves could be shredded by the expanding fabric of space. Imagine that. Not just a universe that ends in silence, but one that tears itself apart piece by piece. There's also a third idea, the Big Crunch. Maybe, just maybe, gravity will someday overpower dark energy. If that happens, expansion will stop and everything will collapse inward. Galaxies will crash together, stars will collide, and eventually the universe will shrink back into a single point, almost like rewinding the Big Bang. And who knows, maybe that point would explode again, creating another universe, a cycle repeating forever. The truth is, we don't know which of these fates awaits us. Heat death, big rip, big crunch, or something no scientist has even dreamed of yet. The universe holds its secrets tightly. But here's something comforting. Whatever happens, it won't be for billions, trillions, or even quadrillions of years. Long after our sun has burned out, long after Earth has been forgotten, the universe will keep going in ways we can only imagine. And maybe that's the most beautiful part of all. We are here right now in this fleeting moment at the height of the universe's brilliance. Among the stars, during the age of galaxies, in a cosmos alive with light. Out of all the times we could have existed, we are alive during the era when the universe is at its brightest. Think about that for a second. You and I are made of ancient stardust, living on a tiny planet, circling a small star, in just one galaxy among trillions. Yet we exist during the time when the universe is full of light. It's as if we've been given front row seats to the greatest show in existence. And so, when we ask, how big is the universe? The answer isn't just about numbers or distances. It's about time. It's about being here, now, in a moment we'll never see again, in a cosmos that will one day grow quiet. So if the universe feels overwhelming, remember this. We're not just spectators of its size. We're part of it. We are the universe, looking back at itself, asking the oldest question, how big am I? Let's slow down for a moment. Take a deep breath. Imagine you're standing on a quiet balcony at night, looking up at the stars. That view, as breathtaking as it is only the very first step into something far larger. Now, let's leave Earth behind together. The first thing we pass is the moon, just 250,000 miles away. It's so close that astronauts once walked across its dusty surface. Yet, already, space feels silent and infinite. A little farther out, we drift past Mars, the red world, a planet that might have once had rivers and lakes, where maybe life once tried to bloom. It feels lonely now, a frozen desert, but who knows, someday it might host life again. Now we slip past the gas giants, Jupiter with its swirling storms, Saturn with its rings like shimmering halos, each one a miniature solar system surrounded by dozens of moons. Some of those moons, like Europa and Enceladus, may hide oceans under their icy shells. Oceans that could, right now, be hiding something alive. Isn't that thought incredible? While we look out at the stars, life might already be staring back under layers of ice. Beyond Neptune, we enter the Kuiper Belt, a field of frozen worlds and comets. Pluto drifts here, small and lonely, but still circling the Sunday. These icy wanderers are reminders of the early solar system, leftovers from the time planets were born. And now we leave our sun behind. It shrinks to just another point of light in the black sea of space. The distance becomes unimaginable. It takes light, the fastest thing in the universe, 8 minutes to reach Earth. But to reach the next star, Proxima Centauri, it takes more than 4 years. Think about that. A beam of light, racing at 186,000 miles every second, still takes 4 years to get there. As we move past, we see Alpha Centauri, our closest star system, glowing with 3 suns. To the naked eye, it looks like one star, but up close, it's a neighborhood of stars dancing together. Keep drifting, and the stars begin to thicken around us. We're in the Milky Way, a galaxy with more than 200 billion stars. Each star may have planets, each planet may have moons, and each one of those could carry its own secret. We pass by the Orion Nebula, a vast cloud of gas and dust where new stars are being born. It looks like a cosmic nursery, glowing pink and purple against the black. Somewhere in there, stars are lighting up for the very first time. Farther still, we pass black holes, invisible giants, bending space around them. Some sit quietly, others tear stars apart, swallowing them whole. And at the centers of galaxies, supermassive black holes hold billions of suns worth of mass, anchoring everything around them. As we drift outward, we start to see the grand spiral of the Milky Way itself. A great glowing disk, arms curling like a pinwheel. From this view, our sun is just a speck, our Earth invisible, hidden in one of the spiral arms. And then we go farther, past the Milky Way, into intergalactic space. Now the universe looks like a vast ocean of galaxies, each one a city of stars, swirling, colliding, merging. Some galaxies look like graceful spirals, others like giant smudges of light, twisted and stretched by cosmic forces. We pass Andromeda, the nearest large galaxy to us, 2 million light-years away. It's on a collision course with the Milky Way. Someday, billions of years from now, the two galaxies will merge, creating an enormous new galaxy. Imagine the night sky, then stars everywhere, brighter and closer than ever. Beyond Andromeda, we drift farther still into galaxy clusters. Immense gatherings of hundreds, even thousands of galaxies bound together by gravity. They look like jewels scattered on a velvet blanket, each one holding billions of stars. And yet, even this isn't the edge. As we move farther, we begin to see the large-scale structure of the universe itself. Galaxies are not scattered randomly, they form a cosmic web. Vast filaments stretching across space, linking clusters together like a spider's web made of galaxies. Between them are enormous voids, empty spaces where almost nothing exists. The farther we go, the stranger it feels. Distances are so huge that numbers stop making sense. Billions of light years stretch before us. We are no longer talking about planets or stars, but the shape of the entire cosmos. And finally, as far as we can possibly see, lies the cosmic horizon, the edge of the observable universe. About 46 billion light-years away in every direction. Beyond it, we don't know. Maybe space goes on forever. Maybe it folds back on itself. Maybe there are other universes beyond ours. We can't be sure. And so, here we are, drifting at the edge of what we can know. Looking back, we see everything. The stars, the galaxies, the cosmic web, all of time and space laid out like a grand painting. And still, the question lingers, how big is the universe? The truth is, we may never know the full answer, but that's what makes it so powerful. The universe is not just big, it's beyond numbers, beyond words, beyond imagination. And somehow, we are here, a part of it, asking the question, close your eyes for a moment, and imagine yourself floating. No weight, no noise, just the gentle hush of space. All around you, stars sparkle like scattered lanterns, each one glowing steadily in the dark. They don't rush. They don't hurry. They've burned for billions of years, and they'll burn for billions more. Their light is ancient, and yet it still reaches you now, softly, quietly, across the cosmic sea. You drift slowly, effortlessly. Behind you, the Milky Way glows like a river of light stretched across the sky. It feels alive, as though you can almost hear its hum, a soft vibration in the silence, like a lullaby. Far below, you notice Earth, a small glowing marble of blue and white, wrapped in a thin halo of atmosphere. From here, it looks fragile, delicate, and unbelievably beautiful. Every mountain, every ocean, every forest, every person you've ever known, all of it rests on that tiny dot, floating in the void. But then your gaze shifts outward. The deeper you look, the more galaxies appear. It's like standing in a dark meadow where fireflies flicker in every direction. Some are close, some are faint, some are so far away their light has traveled since before Earth was even born. And as you drift among them, you realize this is only the part we can see. There's no wall at the edge, no finish line, no sign that says the end of the universe. Just more and more and more. A vastness that never seems to stop. You float past ancient galaxies, their light stretched red with age. They're so far away that you're looking back in time itself, seeing them not as they are now, but as they were billions of years ago. Every point of light is not just a place in space, but a moment in history. And then silence deepens. A stillness so complete it feels like time itself has slowed down. The universe doesn't speak with words. It speaks with distance, with patience, with eternity. It tells us that we are small, yes, but also part of something immeasurably grand. Imagine for a moment that your thoughts are stars, each memory, each dream, each hope glowing softly. Some brighter, some fading, but all connected. Your mind itself is like a little galaxy, full of light. And just as galaxies fill the universe, so do thoughts fill you. You drift farther, deeper. Nebulas bloom in the dark like watercolor clouds, pinks, blues, greens shining softly like petals opening in slow motion. Inside them, stars are being born. Imagine the quiet joy of something new beginning, even in the cold vastness of space. Now picture yourself standing on one of those newborn worlds. The air is strange, the ground unfamiliar, the sky filled with stars unlike anything on Earth. And yet it feels peaceful, as if the universe has wrapped you in a blanket and whispered, "You belong here too." The farther we stretch our gaze, the more mysterious it becomes. Beyond the galaxies, beyond the cosmic web, maybe there are other universes. Maybe endless realities, each one with its own stars, its own rules, its own lives. A multiverse, infinite beyond infinity. And yet, no matter how far we imagine going, there is always a return back to that tiny blue planet, back to Earth, because in all the vastness, it is still home. So here you float between infinity and home, between the unknowable and the familiar, between silence and meaning. And as you drift, a calmness settles. The universe is big, unimaginably big, but that bigness is not frightening. It's comforting. It's like a vast ocean, and we are a single drop. Small, yes, but part of something endless, timeless, beautiful. So let yourself drift. Let the stars guide you. Let the silence of space wrap around you like a soft blanket. The universe is infinite, and in that infinity, there is peace. Imagine floating farther out now, beyond the Milky Way, beyond the familiar cluster of galaxies nearby. You are leaving behind everything you know, not in fear, but in peace. It feels like sailing into a calm ocean where the waves stretch endlessly and every ripple carries starlight. As you move, you notice that galaxies are not scattered randomly. They gather in patterns, like pearls on invisible strings. Scientists call it the cosmic web, the largest structure we know. Imagine strands of light stretching for billions of light years, each strand filled with galaxies upon galaxies. It looks almost alive, as if the universe itself has veins pulsing gently with the glow of creation. You drift along one of these strands, moving past clusters of galaxies so huge they make our Milky Way look tiny. Some are shaped like spheres, tightly packed with hundreds of thousands of galaxies. Others stretch into great chains, bending through space like rivers of light. Take a moment to let that sink in. Each single galaxy could hold hundreds of billions of stars, and you're watching hundreds of thousands of galaxies grouped together, drifting like lanterns in the dark. And yet, it doesn't end. You keep floating outward. Distances grow so vast, they're almost impossible to imagine. Light itself, the fastest thing we know, takes billions of years to cross this space. The stars you see twinkling right now in the night sky, many of them no longer exist. Their light is just now arriving, carrying the memory of what once was. It's like the universe is both a mirror and a time machine, showing us stories from long ago. Now picture this. Beyond the cosmic web, the fabric of space itself stretches. The universe isn't static. It expands like a balloon being gently inflated. And the farther away something is, the faster it drifts from us. Entire galaxies are sliding into the darkness, forever beyond our reach. Even if we traveled at the speed of light, we'd never catch them. They are gone, swallowed by distance itself. It's strange, isn't it, to realize that the universe is not just big, but growing bigger every second. Every heartbeat you take, space itself expands. More distance, more mystery, more silence. And yet, despite that vastness, here you are, listening, breathing, thinking. You, a small human, aware of this infinite stage. Somehow, consciousness itself feels bigger than the stars, because stars don't wonder. Stars don't dream, but you do. Let's stretch this thought further. Imagine time itself as a river. The beginning of the universe, 13.8 billion years ago, was the river's spring. From that point, it has flowed endlessly forward, carrying galaxies, stars, and worlds with it. Now imagine you're drifting on that river. Every star you see, every galaxy glowing faintly, is like a light along the riverbank, guiding your way. And then you wonder, where does this river lead? Will it flow forever, endlessly stretching into nothingness? Or will it one day dry up, collapse back into itself, as if the universe takes one last breath and then falls silent? Scientists call these possibilities the fates of the universe. Some believe space will expand forever, galaxies drifting farther apart until even their light fades away a cold, eternal darkness. Others believe gravity may one day pull it all back, collapsing everything into a single point again, as if the universe itself has a heartbeat, expanding, then falling, then expanding once more. It's humbling, it's beautiful, it's endless. And as you let those thoughts settle, notice how quiet your own mind has become. The vastness makes our daily worries feel smaller. That unpaid bill, that awkward conversation, that long day at work, suddenly they shrink into almost nothing compared to a cosmos that has stretched and grown for billions of years. Take another deep breath. Let the stars exhale with you. You float past a glowing nebula, its colors soft, like spilled paint across the sky. Inside, new suns are being born. Some will burn bright and short, like fireworks. Others will last trillions of years, steady and calm, and around them, perhaps, planets will form. Maybe one will look like Earth. Maybe somewhere, someone else is also wondering tonight, how big is the universe? It's a comforting thought, isn't it? That maybe we're not alone. That in all this infinite space, curiosity exists elsewhere too. That the universe isn't just stars and dust, but questions and dreams. And still you drift, slowly, quietly. Stars fade behind you. New ones appear ahead. No rush, no hurry, just the endless calm of space. The universe is vast, bigger than we can measure, bigger than we can fully imagine. But in this moment, as you float among it, you feel something rare, peace. Because when you realize how small you are, you also realize how free you are. Free to wonder, free to dream, free to just be. You've been drifting for what feels like forever now. And yet, out here, time loses its meaning. A second, a minute, a million years, they blur together when you're surrounded by endless stars. The deeper you travel, the more you begin to sense that the universe is not just a place, but an idea. Think of it like a painting, an artwork so vast that even the greatest canvas we could imagine would be too small. Every galaxy is a brushstroke, every star a dot of light, and together they make a picture too wide for us to ever step back and see in full. But maybe that's the point. Maybe we're not meant to see it all. Maybe we're only meant to see just enough to keep asking questions. You keep moving forward. The galaxies behind you fade until they look like dust on the horizon. Ahead, the darkness grows thicker. This isn't empty space, it's something stranger. The cosmic horizon. Imagine this. There are parts of the universe we will never see, not because they don't exist, but because light hasn't had enough time to reach us yet. Even if you waited forever, those places would remain hidden. It's as though the universe has drawn a curtain, keeping certain secrets out of reach. Scientists call this the observable universe, the part we can see, the part we can measure. But beyond that, nobody knows. Pause here for a moment. Think about it. The universe you and I can observe is already 93 billion light years across. But that's just the observable part. The real universe, it could be 10 times bigger, 1,000 times, or infinite. No edge, no end, just forever. That thought alone can take your breath away, and still your mind drifts deeper. If the universe has no end, then what does it mean to be in the middle of it? Is there a center? Or are we simply part of a pattern so large it loops endlessly in every direction? Some scientists compare it to standing in a forest. No matter where you look, you're surrounded by trees. There is no center, because every tree is both center and edge. The universe could be the same infinite, without beginning or end, without any one place being the middle. It's humbling, isn't it? To realize that Earth, this tiny dot, this fragile home, is just one leaf in the cosmic forest. Yet, to us, it feels like everything. Take another slow breath. In, out. Let the thought of infinity wash over you. Don't fight it. Let it stretch your imagination gently, like a balloon being filled with air. Now, imagine traveling to the very edge of the observable universe, 46 billion light years away. What do you see? Not stars, not galaxies, but something even stranger, a faint glow, a whisper of light left over from the very beginning of time itself. This is the cosmic microwave background, the oldest light we've ever seen. It's the echo of the Big Bang, stretched and cooled over billions of years until it's now just a soft, invisible hum. If you could hear it, it would sound like static on a radio. That static is the afterglow of creation, the literal memory of the universe being born. And you realize everything since then, every star, every planet, every living thing is part of that same story. A story that began with a single spark, a moment of unimaginable energy, and has been unfolding ever since. Now, here's a question that keeps scientists awake at night. If the universe had a beginning, does it also have an end? Or, if the universe is infinite, did it ever truly begin at all? You might picture the Big Bang as an explosion, but it wasn't an explosion in space. It was the expansion of space. Imagine blowing up a balloon, not with air, but with galaxies. The fabric of space stretches, and galaxies ride along with it, drifting apart as time passes. And yet, what was there before the balloon? Before space and time itself? That's where science goes quiet and imagination takes over. Some say there was nothing. Others say there were other universes, whole realms beyond ours, each with its own laws, its own stars, maybe even its own versions of life. That's the idea of the multiverse. A collection of universes, like bubbles in an endless cosmic ocean. If that's true, then what we call the universe is just one bubble. And somewhere out there, maybe another bubble has different stars, different physics, maybe even another version of you. It sounds like science fiction, doesn't it? But the more we look into the sky, the more possible it begins to feel. As you float here, listening, picture yourself standing on the shore of that cosmic ocean. Billions of universes drift past like bubbles, each one sparkling for a moment, then vanishing into the dark. You can't see them all, You can't touch them, but you know, somehow they're there. And suddenly, you don't feel small anymore. You feel connected, not lost in infinity, but part of it, part of the same story, part of the same beginning. So you keep drifting, slow, calm. The stars ahead grow fainter, the silence grows deeper. But in your mind, the universe grows bigger, bigger than light, bigger than time, bigger than anything words can hold. And yet, here you are, resting, breathing, aware, a small piece of infinity, experiencing infinity. The universe keeps expanding, faster and faster, as if some unseen hand is pulling it apart. That mysterious force is what scientists call dark energy. We don't know what it is. We can't touch it, but it makes up almost 70% of the universe. Imagine that most of existence is something we can't even explain. It's like standing in a room filled with furniture and realizing that all you can actually see is the dust in the air, while the real substance, the thing holding it all together, remains invisible. Dark energy pulls galaxies farther apart. One day, in a distant future we'll never see, galaxies might drift so far that no light from them will ever reach us. The night sky, instead of glowing with billions of stars, could fade into emptiness. A lonely silence, stretching forever. But right now, we still have the stars. We still have the light. And some of that light comes from the most mysterious objects of all, black holes. Imagine a star so heavy, so massive, that when it dies, it collapses under its own weight. It doesn't just vanish, it folds space itself, tearing a hole in reality. A black hole is gravity turned to its maximum setting, a place where time slows, where light can't escape, where the very fabric of existence bends inward. And yet, black holes aren't just destroyers. Some scientists believe they might even be gateways, portals, perhaps to other regions of the universe, perhaps to other universes altogether. What if on the other side of a black hole, another universe is born? A bubble breaking off from the foam of infinity. If so, maybe our universe itself began as the other side of some ancient black hole. Maybe we are inside someone else's creation, and maybe one day new universes will bloom from ours. It's dizzying, isn't it? The universe is so big, so deep, that even our most powerful minds can only sketch faint outlines of what it might be. And yet, here we are, small, fragile beings, asking the biggest questions of all. You feel the quiet as you drift farther. Stars thin out, darkness deepens. But even the darkness is alive with mystery. Every particle, every ray of light, every bit of energy is part of a pattern we're only beginning to understand. The universe is not just big, it's beyond big, beyond words, beyond numbers. It is both endless and intimate, both ancient and new in every moment. It is the stage where galaxies dance, where stars are born, where life somehow found a way. And in all of this, there is you, listening, breathing, thinking about infinity. That's the real magic. Out of all the billions of galaxies, all the trillions of stars, and all the uncountable planets, there is exactly one place where the universe can look back at itself through your eyes. Take a deep breath. Let it fill you. Let the thought sink in. You are the universe, aware of itself. So, how big is the universe? Bigger than numbers, bigger than imagination, big enough to hold everything that ever was, everything that is, and everything that ever will be. And yet, somehow, it fits inside your mind. Close your eyes now. Let the stars fade. Let the silence wrap around you. You don't need to chase the edges of the universe anymore. You are already part of it. You always have been. And as you drift into rest, remember, the story of the universe is still being written. And in your own way, you are part of that story too. If you enjoyed this journey tonight, subscribe and stay close because the next video waiting for you is already glowing on the screen. A new mystery, a new question. And I'd love for you to come with me, once again, into the endless night.